Okay, for what we have in the case of determining whether we have a linear equation or not, okay, we have working with the variables x and y. Okay, now for the equation to be linear, okay, the graph must be in the appearance of a straight line. Okay, and now for what we have in the first item, okay, we have 2x plus y is equal to 3. And for what we have here, okay, so x is a first order and y is also a first order. And throughout, okay, we're going to have the equation is going to be linear in both x and y. X is kept linear and so is y. So in the case of the first item, okay, that is going to be a resounding yes. Okay, and looking at what we have in terms of the appearance of 2x plus y is equal to 3. Okay, so we have this particular image. Okay, so for what we have concerning 2x plus y is equal to 3, okay, again we have for this image, okay, that is going to be a straight line. Now, for 2x plus 5xy is equal to 3, okay, notice we have 2x's, that term in a sense is going to be linear, but with 5xy. Now, if I had 2x plus 5y is equal to 3, I would have another linear equation. But in the case of 2x plus 5xy, now let's say that if x and y happen to be identical, like you could have 2x plus 5x squared is equal to 3, or 2x plus 5y squared is equal to 3, and the combination of x and y could possibly be of a degree other than just 1. Okay, so x is variable, y can be variable, and the product first order variables when paired up comes out to 2. So in this case we have for this item, okay, the result is absolutely no. And for the image of 2x plus 5xy is equal to 3. And if you notice, okay, we have in this image, okay, like if I had solving for y, I would have a rational expression where we would have the graph to be split up, okay, where we would have involving vertical as well as horizontal asymptote. So in this case, we have the second equation to be nonlinear. Okay, now for what we have in the case of the third equation, now we have cosine of x plus the sine of y is equal to 0.7. Okay, now cosine of x, okay, that is a variable, and the rate of change is anything but constant. Likewise, we have with the sine of y, both cosine and sine are nonlinear functions. And so the combination of nonlinear functions in this case is going to be nonlinear. Okay, so this result is going to be no. And just for the appearance of the cosine of x plus the sine of y is equal to 0.7, I'm just going to put up that image. Okay, and for what we have in the appearance for the cosine of x plus the sine of y is equal to 0.7, and this is going to be an infinite assortment of what we have with these particular images, which we have to be anything but linear. Okay, now let's say that for the fourth item, okay, say we had the cosine of x times y is equal to 0.7, and for here the cosine of x is nonlinear, and we have times y is equal to 0.7. Okay, and for what we're going to have here, okay, it's going to turn out that for the cosine of x times y, okay, we have like a nonlinear times y equal to 0.7, so the result here is going to be no. And for what we have in this particular case, okay, so for the cosine of x times y is equal to 0.7, okay, you're going to have an infinite assortment of these particular graphs. And so we have anything but a straight line that is going to appear. All right, now for what we have in the case of the next item, okay, so we have with the cosine of 3 times y is equal to 0.7. And now the cosine of 3, okay, this is going to be a constant. Okay, because we're looking at the cosine of 3 radians. And a constant times y is equal to 0.7. If you have like a fraction, okay, it could be a rational number, irrational number, as long as it's a real number, times y equal to 0.7. Okay, that is going to be a case of what we have with the linear equation. Okay, so you have the cosine of 3 radians times y is equal to 0.7. And just to show the image that we have on this, and for what we're going to have is going to be the appearance of a horizontal line. Okay, so the cosine of 3 radian, okay, times y is equal to 0.7. Okay, so you have the graph of this function is going to be a straight line. And now, while the cosine of x plus the sine of y is equal to 0.7 is nonlinear, let's say that if I had the cosine of 1 radian times x plus the sine of 1 radian times y is equal to 0.7. Now, upon first glance, okay, equations 3 and 6 appear to be the same, but the cosine of 1x is not the same as x times the cosine of 1 radian, nor is the sine of 1y the same as y times the sine of 1 radian. So you have like a constant times x plus a constant times y. Both x and y are a first order, and so we're going to have a linear equation, kind of like the very first item that we have in the set. So just looking at the appearance of what we have with this last case, and for the outcome here, okay, that is going to be in the appearance of a straight line. Okay, so all in all, an equation that is linear in x and y should have the features to be such that the graph will be in the formation of a straight line.